No engine currently exists that can reach 90% the speed of light, 0.9 c, but based on theoretical physics and speculative engineering, here are the types of engines that could achieve that speed. If you're fascinated by futuristic engines, space travel, and the mind-blowing science behind reaching 90% the speed of light, make sure to subscribe. We dive deep into antimatter drives, laser sails, and more tech that could one day take us to the stars. Hit that like button, tap the notification bell, and join us on this journey into the future of space exploration. Antimatter Engine converts matter plus antimatter into pure energy. Most efficient known, up to 0.9 cents C possible. Problem: we can't produce or store enough antimatter yet. Photon Rocket uses light, photons, for thrust, can approach light speed, needs huge energy and near-perfect efficiency. Fusion Drive uses nuclear fusion like the Sun, could reach around 0.3 cents C, not 0.9 cents C yet, still experimental. Laser Sail. Earth-based lasers push a light sail, can reach around 0.2 cents C, only works for tiny probes. Black Hole Drive. Kugelblitz. Hypothetical engine powered by mini black holes, could reach 0.9 cents C plus, pure science fiction today. Making antimatter is extremely difficult, expensive, and currently only done in tiny amounts in advanced physics labs like CERN. Here's a simple explanation of how it's made.
High-energy collisions. Powerful machines called particle accelerators, like the Large Hadron Collider at CERN, smash particles like protons together at near light speeds. These collisions release huge energy, and Einstein's equation, E=mc², allows some of that energy to turn into matter and antimatter pairs.
Antiparticles Created. For example, a proton might be created along with its antimatter twin, an antiproton. Likewise, positrons, the antimatter version of electrons, are also made. Trapping antimatter.
Antimatter annihilates on contact with matter, so scientists use magnetic or electric traps, like a penning trap, to suspend them in a vacuum and prevent them from touching normal matter.
Challenges. Extremely low yield. It takes billions of collisions to produce a few atoms of antimatter. Very costly. Just 1 gram of antimatter could cost trillions of dollars to produce with current technology. Dangerous. If antimatter touches regular matter, both are annihilated, releasing a huge amount of energy. Antimatter is made today, but only in CERN, Switzerland, Fermilab, USA, GSI Helmholtz Center, Germany. How an antimatter engine would work, step by step. 1. Create antimatter. What? Usually positrons, anti-electrons, or antiprotons. How? Created in particle accelerators, like CERN, by smashing particles at high speed. Problem: very expensive, $25 billion per gram. Only nanograms produced so far. Takes more energy to make than it gives back. 2. Store the antimatter. Why? Antimatter annihilates if it touches matter. Solution: store in a magnetic or electric trap, penning trap, inside a vacuum. Challenge: perfect isolation needed. Any failure equals explosion, not scalable yet. 3. Control the annihilation. Idea: mix matter and antimatter in tiny amounts. Result: total mass converts to energy via E=mc². Use: direct energy as thrust, like a nuclear engine, but way more powerful. 4. Design the propulsion system. Options: thermal propulsion, heat propellant with antimatter and expel it. Photon drive, use gamma rays from annihilation directly for thrust, very hard. Magnetic nozzle, channel charged particles from annihilation into thrust. 5. Protect the spacecraft. Needs shielding from radiation, gamma rays, positrons, heat from the reaction, cosmic particles at near light speeds. So, while an antimatter engine could one day take us to the stars at 90% the speed of light, we're still a long way from turning that dream into reality. But every great leap begins with imagination, and today's science fiction could be tomorrow's science fact. If you enjoyed this journey, don't forget to like, subscribe, and hit the bell icon so you won't miss our next deep dive into the unknown. Thanks for watching, and see you in the next video.